then make a pie chart.
Yeah, so I remember talking about weighting data. Do you weight it before you make the pie chart? Always? Or is that?
It just depends. It depends on if, let's see, summaries. Well, like, let's try to do it without it. Like,
okay.
So we go graphs and legacy and pi, and what defined by slices by the reason we're doing this. And what are we trying to find out?
It says
class rank.
Create a pie chart for class rank. Yeah.
So can we just put rank on that?
I think so. Yeah.
And then okay.
On the variable?
Yeah. On the slices thing.
Oh.
You see what I'm saying?
So do you click summary separate variables?
Oh, yeah.
So let me go back. Let's see. So graphs, legacy, pi, and then define. You just push define. And then beyond that?
Yeah.
Yeah.
Is it, but do you do summaries for groups of cases?
Yeah, the top one, just push define, don't change anything.
Okay.
And then it says, on the second one down, it says define slices by. And it looks like it's asking us the rank. So
yeah, so that's where you put rank.
Just put rank in there and then push OK.
Okay.
And then I'm thinking that'll give us a pie chart. And then label it. To label it, you double click on that chart. Right? Let's see. How did that didn't work for me? Double click on it, and then it comes up to
you left
the
click
Explore
or
option.
Right click? Oh.
Right.
Okay. Chart editor.
And you're going to go variables. No? Is that right? No. Trying to remember.
I don't remember labeling it. I'm trying to remember where we labeled it too.
I did. I labeled it. Let me try to remember how I did it. Okay, so data weight variable. Double click supply and then go explore. I think you go to variables first, though. Graphs legacy. Double click, edit properties.
So I've got rank, but I don't.
I'm trying to remember how I did it. The Pi Explorer.
On their one, they didn't change the variables.
Okay, it's Explore, but I don't know how you get to the Explore thing. Sometimes I have a harder time getting to the Explore. I remember how to do it. It tells you in the, you can go back and tells you in the SPSS homework thing, you know what I mean?
Yeah.
Let me see if I can get back there.
Do you not remember where it told you how?
Yeah, you just go on, what's that, we're on week 13.
16. 16 is the lesson.
Is it for how to weight? No.
Yeah, because it only tells you how to weight in there. You can change.
Is it asking us to label?
Well, you can. No, it doesn't. But you can label them on a bar graph. On the pie graph though, online it says the pie graph that we got without labeling it says it's correct.
Okay.
Okay, so without the labeling. So
yeah,
we don't need to go any further.
Yeah. Now it says create a bar graph.
All right, so maybe that's what we'll do it that way. So on the answers, it didn't have any labels on it because I did it on my Yeah, it has like
Yeah.
well, if we need to do that for the test, we'll figure it out because I know how to do it. So we'll figure it out.
Okay, bar graph now.
Yeah. So that's graphs, legacy, bar.
Bar, and then move
Simple.
reason into the category axis. Rank. Was it rank we were doing again? Yeah.
Yeah, we're doing rank.
Into the category.
Right.
And then that's it. That
Yeah.
already.
I think so.
Okay, and label it and post it.
So we've got count versus rank. Let's see. Yep, that's exactly how it's supposed to look. Okay, use at least 5 descriptors to describe the data above.
Wait, on your guys' bar graphs, does it look exactly like the one in the answer key?
Yeah, mine does.
Because mine doesn't have those percentages like on the bars.
So, oh no, those percentages, I don't remember how you get those. Mine doesn't have those either.
Oh, okay. Okay.
But we can't. It tells you in the homework. So if we need to do that, we'll go back and figure out how to do that.
Okay.
Yeah.
It's just an extra. It's an extra thing you click on.
So what is 5 descriptors?
By statistics, and then you go. Oh, I know how to do ascending to descending, but that's not what we're looking for. I know how to do the next ones where you do that. Oh yeah, there's just one little thing you click on. You double click on one of the bars, and then you
have
variables, and then you go. No, it's not variables. Anyway.
I don't remember how to do it either.
Editor.
I'm in the chart editor. Is that where you're at?
Yeah. How do you get to the chart editor?
You double click on a bar.
On just the whole, on one of the bars or on the whole thing?
Yeah, on the whole thing basically, but one of the bars is fine.
And then there's something you push on that says to allow that, and it's categories, I think.
I told you in the lesson.
Yeah.
I don't even remember doing that in the lesson. That's interesting. And it was called categories, you think?
Yeah, the categories is when you go to the categories, you can go sort by and then turn it into statistic, and then go to the descending, and then that turns your graph into the one that.
Oh yeah. I remember doing that with bar graphs. So you go.
So I know how to do that, but that doesn't.
Edit properties and then.
Yeah, categories, and then sort by, and then you change that to statistic.
Oh, I don't even have that many options in my bar. Or was that with a barriograph or whatever it was called?
Yeah, that was with the other one. That's not going to give us the percentages. I keep on getting into the wrong thing because I can't get into the editor for some reason. I don't know why. Anyway, I double click on the graph and it doesn't give me the editor for some reason.
Maybe just keep clicking on it and see if it opens it. Like triple click.
Triple click. Simple, define, and then you go to rank and then options. Maybe that's it. No?
Add text box. You can add text boxes. Insert shown data labels. Display count.
Explore.
Yeah, I got
How do you
it.
get to the Explore? Just double click on the graph.
Yeah, just double click is how you get to chart editor.
Okay, I'm on chart editor. And then what do you do when you're on chart editor? Options? View.
Yeah, so when you're a chart editor, you right click, and
Okay.
you click, says, let me see, I'm opening it. Oh, you have to click on a bar. You have to right click on a bar, sorry. And then you
Okay.
click show data labels, should be down there.
Okay.
And then when you click data labels, it says not displayed and displayed, and you can move them up or down. So you can put percent. If you move percent up, then
so
it
we're going to
makes
put
it.
rank up on the top one.
Yeah. And then you can put percent. That's how you label it.
So you put both of them up there and then apply it?
Yeah, you can. But in the question, it's actually puts both. So yeah, put both.
All right, so that's not exactly the way they showed us in the lesson, but that got us there, so perfect.
Yeah. Okay. So number 9, I think is what we're on. It says, this is where we're going to do some calculations. It says 7% is the true known percent of a population.
Wait, did we do 8?
Yeah, 8 was just describe the data with labels.
Describe 5 descriptors.
So you could.
What does it say on the answer, that is?
It says may vary. You may use proportions to describe it. You may describe it with words. You may use a frequency table, which we put up with our labels.
All right.
Okay, 9. So 7% is the true unknown percent of the population. Do not have traditional phones and instead rely on cell phones. So 7% is P. Suppose a random sample of 750 telephone users is obtained. What is the probability that more than 60 phone users, 8%, in this survey use only cell phones? What is the mean and the standard deviation of the sample distribution based on the 750 telephone users?
Okay, so the mean would be the 7%, the 0.07.
Right, because that's your sample size per percentage. And then
the standard variation, we go the square root of P times 1 minus P over N.
Yeah, so the square root of, what's the standard deviation in this one?
We're trying to figure it out. So we go P, which is 0.07
P. Yeah,
times
0.07.
1 minus 0.07, and then the N is 60. So we just figure that out, and that will be our standard deviation.
N is, well, isn't the N 750 in this case?
Oh, yeah, you're right. 750 in this case.
Okay. So the square root.
I got 0.009.
0.07 times 0.01 divided by 750.
And then we have to square root the whole thing.
Right.
Right?
Yeah, so you said you got 0.009?
Yeah.
3?
Yeah, I did too.
Okay. B, state the problem in terms of the variable p hat.
I don't get what that means. What's p hat?
So p hat is equal to your mean.
Oh. Okay.
So,
I think that's what the book
what
said.
is that asking us? I don't understand that either.
So it's asking us basically to show how you got.
The 8%?
Yeah. So it's basically.
We're supposed to do the 8% or the 7%?
In this one, you're supposed to do
8.
8.
Okay. So how you get p hat is we're just getting the percentage. So we go.
Yeah. So it's basically 60 divided by 750.
Okay.
The p hat is just the percentage, basically.
Yeah. Well, in the lesson it said that p hat is equal to p, or the mean of p hat is equal to p. So the sample p hat is normally distributed if large. The true population mean of a random variable is p hat. So this is the true population mean of a random variable.
Okay.
And the mean is equal to p.
Okay.
Okay, so 60 divided by 750 would give us 8%.
Right.
But it's saying in here that p hat is greater than that number.
What?
Yeah, it says p hat is greater than 60 divided by 750.
Oh, because that's the question we're trying to figure out.
I don't know why they got greater than.
I think
Because what is the probability?
You're trying to find something that's more extreme, and so they just put that so you know what to shade for the probability curve.
Oh, probably.
Yeah, because on 9 it's asking us what is the probability.
Oh, yeah, what is the normal?
It's more than, so that's why we put it that way.
Oh, so p hat is more than. So we put.
So then when you do the curve, you just shade above it.
Yeah.
Yeah.
Yeah, the area to the right.
Right.
Okay, so D is find the z-score.
So of 0.08.
Yes. So I think it's 0.08 minus 0.07 divided by our standard deviation.
Oh, we have to do the z-score before we can plug it into there. Okay.
Oh, our standard deviation divided by n, which was, yes, that was our standard deviation. So 0.00093. Let's see if that's what we're supposed to do.
And then p hat is 8. I mean 0.08 and p is 0.7? 0.07, is that what we're thinking?
I think so, but I'm not positive.
I think so too.
But I'm getting way too big of a number, so I'm doing something wrong.
I got 1.07.
What was it? Was the z-score, did it have 3 zeros or 2? 2. Oh, that's why I got it wrong. Yeah, I got .1072.
Wait, 0.107?
Or sorry, 1.07.
Okay.
Yeah, it was 2. I put 3 zeros in there too. It's only 2. 0.0093. And so it's 1.075.
I got 3.
Yeah, I got 3 too. 3 also.
You got 1.073?
Yeah.
So 0.08 minus 0.07 divided by 0.0093.
The square root of that.
Oh, and then the square root.
Wait, do you square root? No, because we already square rooted it. I actually got.
You're
already
right.
got-
0.093 isn't
I
square root.
didn't put. I did like the whole square root problem. I didn't just type in.
Oh yeah, I gotcha. That's why you're getting 7.3. Okay.
So 0.8 minus 0.7 divided by 0.0093. We got 1.075.
Well, the 5 comes because you rounded your standard deviation.
What was my standard deviation without a round? Do you know?
I don't, but
But
that's why,
it's 3 then. Okay.
Yeah, that's why Mackenzie got a more closer
because
number,
she did
she put the
rounds.
whole thing in. Yeah.
Got it. Okay. So then we
Okay.
put that in our app.
Yeah, the applet.
Let 0.073. So we just put 1.073, and then we're shading to the right.
Yeah.
Yes.
Okay. Okay.
Oh, 0.1416.
Wait. Oh, okay, never mind.
0.1416.
Yeah.
So there is a 0.1416 probability that more than 60% of users, or 8%, use only cell phones. From our question.
Yeah. That's how we interpret it. Is that what you're saying?
Yeah.
Okay.
We just answer the question, basically.
Yeah. Okay.
Okay.
Are we done?
Yep, group quiz. Okay, the first one is, everybody there?
Yeah.
Yep.
Why? Okay. In a pie chart, why are the slice sectors different sizes?
Each slice represents a category, and the area of each
Area
slice
of slice.
proportion.
Yeah, right. Isn't it that one?
Yep.
Okay, how are bar charts and Pareto charts related?
The bottom one. The only difference between a bar chart and that is the bars are ordered largest to smallest.
Yeah.
So they're the same, like, they're basically the same graph, except they're just arranged from, like, greatest to least or least to greatest, right?
Yeah, when you get a bar chart, when
Yeah.
you do a
Random.
Pareto chart, you just
Yeah.
click on the bar chart and change that.
Okay.
Okay. We conclude that p hat is normally distributed if np is greater than or equal to 10, or n times 1 minus p is greater than or equal to 10. Is p the true proportion or the sample proportion?
The sample.
Isn't it the true?
That's p hat. Yeah, p hat is.
P hat is the sample.
Yeah, p is the is the true
Okay, what is n? Sample size, right?
sample
Yeah.
size.
If p were equal to 1 divided by 4, what is the smallest n that satisfies this requirement? Just put that in and solve it.
How do you solve that?
So, I mean, you just write the equation. So, n times 1 minus p, which is 1/4, is greater than or equal to 10. So you can go 1 minus 1/4 is 0.75, and so divide 10 by 0.75. So n would have to be greater than or equal to 13.333 is what I got.
Okay, I have no idea how you did that. So give me one more.
Okay, so just plug your p in.
Into what?
Your equation at the top, because it's talking about if it's normally distributed.
My equation at the top.
Yeah, so np is greater than or equal to 10, and
Okay. So my p is
1/4.
is 1/4 is so it's 0.25.
Yeah.
So then you get 0.75. But then,
The other one you get 40.
Okay, so I plug my p in, which is 0.25, and then what do I do with the n?
Okay, so that's where I'm getting this is where I'm a little bit confused, because you have to make sure that they're both right.
You have to just make sure that they're both greater than 10.
Yeah, so they're asking what is the smallest n that satisfies this requirement.
I thought it was just 10. I mean, am I just being silly? If it has to be greater than 10, I thought it was 10, so that's why I'm just like confused.
Well, it wouldn't be 10 because you're going to multiply 10 by 1/4. So
that's what we do, is just multiply 10 by 1/4?
well, if you do that, then you're going to get 0.25, and so because it's n times p, so if you put n as 10, so times 10 by 0.25, you're going to get 2.5, which is not greater than or equal than 10.
Right.
So we have to basically solve it. So by solving it, you would put n we don't know, but p we know is 0.25. So if you take p 0.25 and divide it by 10, that should tell you what n would equal.
Okay,
if that makes sense.
0.0025.
13.33.
Yeah, so you get 13.33 on the one equation, but you get 40 on the other equation.
So the smallest is 13.33.
I think so.
Okay. Do we do 333 just in case?
Yeah, I think it's... Is that what you put as the 333 or just 2 3s?
333, but I'm not really sure that that's actually correct. I don't know how you get both of them to be correct.
You don't. They're not going to both be the exact number. You just have to make sure they're both greater than 10.
But if n was 13.333 on the other one, then if you times 13.333 times 0.25, then it's going to be 3.33, which is not greater than or equal to 10, if that makes sense.
Yeah.
Okay, so no, because p is 0.25. So if you plug it all back in, so 13.33 times 1 minus 0.25 equals 10, and so that's equal or greater to 10.
Right, in the one equation, but remember there's two. There's another one that's NP is greater than or equal to 10. That's where I'm confused, because I'm not sure how you find the smallest that satisfies both. Let me look in the lesson real quick again. Because it says, we can apply central limit theorem if both conditions are satisfied. It's important to check both conditions. If one of them is not satisfied, we cannot conclude that it is normally distributed. So what about, I'm trying to think of what I've been learning in my other math class. So n is equal to or greater than 10 divided by p. So we can plug n in into the other equation as 10 divided by p, 1 minus p, but that's not going to help us find n.
I'm still baffled about this whole problem. For some reason, I don't remember trying to figure this out, and if we don't know what n is, if we know what p is, that's what we're trying to figure out.
But the same thing is on, never mind. Wait, no, yeah. The same thing is for the other equation, so, like, it's just, because, like, if you plug 40 back in, it would still 40 times p
would be greater than 10.
Yeah. Well, it equals.
Maybe it's 40.
Huh?
Maybe it's 40 then.
Where did we get 40 from?
What is? Yeah.
40 is 10 divided by 0.25.
Oh.
Because if you put 40 into this, it would make it greater than in both of them. But I don't know if that's the smallest.
Well, if you put, for either one, when you plug it back in, they both turn out to be 10, of course. But, so 13, the 13 one would be the smallest n that we got.
Other than it wouldn't satisfy the other one, if that makes sense. That's where I'm, because they both have to be satisfied.
Yeah.
So I think 40 is the answer, but I don't know. maybe we'll just move on.
Yeah.
Okay, 8. Use the following information to answer the question. Suppose that n is 24 and p is 0.4. What is the mean of p hat?
Is it 0.4?
Yeah.
Yeah. What is the standard deviation? We can solve that one.
P minus 1.p divided by n.
And the square root of all that.
Yeah. 0.04 minus 1.
Well, it's 0.4, not 0.04, right?
Yeah, 0.04. It's actually, I think it's,
0.4. Just 0.4, you're right.
yeah.
And then the n on this one is going to be 24.
So I got 0.1.
I'm just about to. You got 0.1.
Yeah.
I got 0.221. So
Oh, what?
let's see.
I
Okay.
got 0.1 too.
Let me see what I'm doing wrong here. 0.4
Times 1 minus 0.4 divided by 24. All that divided by 24. And then the square root of all of that.
1 minus 0.4 equals divided by 24 equals square root. Yeah, I got 0.1.
divided by, what is it, 24?
24.
Oh yeah, I got 0.1 now.
Okay.
Use the following information to answer 10 through 13. Brittany's batting average is 0.300. We want to determine the probability she'll get more than 35 hits in her next 100 at-bats. So n is 100 and p is 0.3. What is p hat? 0.3?
Mm-hmm.
What is the standard deviation of p hat?
0.3 minus 1 minus 0.3. And the n is 100?
Right. And it's 100. I got 0.046.
0.046.
You got to?
That's not what I got. Oh, wait. 0.04. Wait, no. I got 0.046.
Yep.
Yeah.
Oh, okay. I thought you were... Okay. Sorry.
Yep. So the z-score is p hat minus
So
p. What's p hat? P hat is 0.
it's 35 divided by 100, I think.
Oh, yeah.
Isn't that what we did in the last one?
So 0.35.
I think that's what we did in the last one, isn't it?
35 divided by 100. Yeah, that's how you get p hat.
So that one, so it's 0.35 minus 0.3.
Divided by 0.046.
But you probably want to not round, so you might want to put your standard deviation completely back in.
Oh, okay. Good idea.
I got 1.091.
Yeah, me too.
Me too.
Okay. What is the probability that she gets at least 35 hits in her next? So do we do greater than? Because it's at least.
More. Yeah.
So,
You'll get more than 35 hits, so it's greater than, right?
Yeah, that's what I think.
1.091.
wait, so do we put that in the applet?
Yeah,
Yeah.
and we shade the greater than.
So put
So I got 0.138.
1.09.
One.
0.1 1.38.
Yeah, me too.
Okay, if the true portion of people who supported a political candidate is 0.52 and N is 2,000 people, we want to determine the probability that the results of the survey will suggest that the candidate is losing the election, getting less than 50% of votes. What is the standard deviation of p hat?
So we have to do the standard deviation thing again. So we go 0.52 minus 1 minus 0.52 over N is 2,000.
I think so.
Point 0.011.
2,000. Yeah, 0.0112. Or 11.
0.111.
Yeah, 2 ones.
You have 3
Okay.
ones.
Well, there's more ones.
0.11, just 2 ones. That's because it's 4 ones. Yeah. Okay.
What z-score would you use? Okay.
So then we plug in that. So we go 5 because we're doing half, right? Because this is a candidate, so the winning team is 5.
Yeah, so 0.52 divided by 2,000 minus 0.52, I think.
I think it's different. I think it's the z-score is the p hat minus p. One of them is 0.5 and one of them is 0.52.
Oh, yeah, getting less than 50% of the votes. Yeah, so you're right.
So which one's 0.5 and which one's 0.52? P hat is 0.5.
0.5, I would assume, because p is equal to 0.52.
So it's 0.5 minus 0.52 over the
standard deviation.
Which I kept up is 0.11171392.
Yeah. So I got negative 1.79.
Me too.
So that's the answer. That's what we put in.
79. I'd put 0.179. Is that what you guys got?
No, I got negative 1.79.
Yeah.
Oh, I thought you said 0.
Yeah, I did. I was looking at it.
Okay.
Funny.
Hey, wait 1 second. I'm still doing it, so I want to make sure I get it right. Oh, I got an error. Okay, so I go 0.05 minus 0.52 divided by 0.011171392, and then I do the square root of that.
Yeah.
You do square root.
Well, no, you don't do the square root if you've already done it. It's just your standard deviation.
Okay, so I'm getting a totally different thing. So walk me through it again. So it's 0.05 minus 0.52.
Just
Yeah.
0.5, not 0.05.
Oh, okay. 0.5, you're right. That's where I'm doing it right. Okay, 0.5 minus 0.52 divided by that big number.
Yeah, your standard deviation.
1.1392. And it's negative 1.790.
Yeah.
Okay, I put 0.05, so that's why I was getting like a way different number. So.
Okay.
What probability do you compute using the normal probability applet? The bottom one, I think.
What probability do you? What?
Well,
on this one, because we're trying to decide if it's
less than. Yeah.
It's the bottom one.
Yeah, I think it's the bottom one.
Yeah, if it's less than, I think that's right.
What is the probability of the survey results will show that the candidate is losing even though the true P is 0.52? So less than 0. What did we get? -1. 79.
Negative 1.790.
0.037.
Yeah. That makes sense, I think.
0.037.
It's a
Yeah.
really small probability that he's losing, because even though that he's getting
Yeah.
more than 50% of the votes.
Okay.
Mm-hmm. Okay,
Uh,
so back to number 7. I think I'm going to keep it as 13.33.
Okay.
I'm still completely baffled by that one. I don't know. I'm just like not awake enough this morning to realize what I'm doing.
I guess we'll submit it and see what it says.
Yeah. Are you doing 40?
Yeah, I'm going to do 40.
Okay.
I don't know what
Then we'll learn.
it is.
All right,
Okay,
I got it right.
I got it right.
All right. So,
I got 10 wrong.
yeah, me too. What?
Well, so how did we get that one wrong?
I don't know. Because it says, what is p hat? And if p, in this case, was 0.3, I don't know how you get that wrong.
Did we need to put zeros after it?
Maybe.
Well,
So, okay, I get how to do the other one, though, that one that I got 40.
yeah.
Okay.
So basically what you're going to do for when they ask you these questions is plug p in to your first equation. Your second equation doesn't matter.
To your first equation. So P is on this one.
So if you go n times 0.25 is greater than or equal to 10, and just assume that that greater than or equal to 10 is an equal sign, and you're solving the equation for p, or for n, I mean. That makes sense.
Okay, n times 0.25
is greater than or equal to 10.
Okay.
So if you assume that's true, you're just going to divide your 10 by 0.25, because then you'll only have your n on that one side.
Right.
And so 10 divided by 0.25 is 40.
Mm-hmm. So
And
then
the reason, yeah, so 40 is the lowest. The reason why 13.3 is not the lowest is because if you solve for 13.3 and you plug n times 0.25 equals 10, it's not going to be greater than or equal to 10.
All right, I get it.
So just do the first one. Just solve for the first one.
Yeah, because the second one will never satisfy the first. The first one is basically it.
And so the way we
satisfy the second.
So the way we solve it is we plug in what we have and solve for n.
Yeah.
Okay. And so that's why it was 40. I just did 40 because I believed you. I just didn't know why, but now I get it. So that's good.
Yeah.
But the other one, number 10, do you think we were just supposed to put zeros after it, or are we just...
I don't know. I have no idea.
Okay,
I don't get that one.
For 10, you guys put 0.3, right?
Yeah,
Right.
but, like, go up to the other one. Oh, it says what is p hat, not what is the mean of p hat.
Right.
That's why.
Yeah.
Oh, so we needed to do...
P hat was 335 divided by 100. 3.5.
Oh, shoot. That's exactly right. So p hat is the proportion.
Yeah, that makes sense.
Yeah. Okay.
So that would have been 0.35.
Yeah.
Oh. Well, that's awkward.
Yeah. Okie dokie. I will post the broadcast.
Okay. Now don't go anywhere, because are we supposed to start doing our thing?
I saw that.
Yeah. What do
I
you
wasn't
think
sure
about
what
that?
it was. Final project overview.
Yeah. I think we have something due this Saturday or something.
So it's actually, I think you just mark it as complete, but I think that it says you and your group will complete a final project. Project is divided into steps. The first 5 steps are the same steps you have seen in the readings. So each of your 6 steps will be written by a different group member, except for step 2. Everyone will write and upload their own document for collect the data. All members of the group should provide ideas and give feedback. Please collaborate together on each step. Each time the main writer completes a document, they need to provide an opportunity for all group members to give feedback. Please write below which group members will be the main writers for each step.
So we got to figure out what we're going to do for a project.
Yeah. So basically, right now, what all they want us to do is to decide who's going to write each one, and then by Saturday we'll have to.
Whoever has the design the study needs to have that. We have to figure out how we're going to do that. Right?
Yeah.
Okay. Does anybody have any ground ideas on what to do?
I've been thinking of this actually, but I'm not sure just yet. I want to do a medical-based one because we're a biostatistics class, but.
Right. Okay, so we have to decide who our group is we're gonna do, right?
What do you mean?
Like who we gonna survey, or what's the group?
Yeah. So, I think that all we need to do right now is we'll just say you're going to design it, you're going to describe it, you're going to make inferences, you're going to take action, and then we have to make a PowerPoint presentation together. If that makes sense.
Hello? Hello? I don't remember. Let me look it up and I'll text it to you. I'm in a meeting. Jeff, you have it right this second? Okay. Let me look at it. Hold on. I'll just text it to you, okay? Okay, bye. Okay, well, does anybody have any ideas for the study? Does anybody want to do that?
I can do it. I can think of some ideas and get back to you on Wednesday.
Okay. Describe the data. I mean, it's nice to say we're gonna like do these individually, but shouldn't we like all kind of help all of them?
Well, it says that, but what it says is that the main person is supposed to like write it up, and then the group members will give feedback and everything like that.
Okay.
So I'll design. Who wants to describe?
I can.
It doesn't matter to me.
We'll have, because make inferences and take action are like basically the same thing. So whoever does that will probably just have to do both of those. So who was going to describe? Mackenzie? You want to describe?
Sure, yeah.
Okay. Mackenzie describes, and then Teresa will have you do make inferences and take action.
Okay.
So when we come back, that's all we have to do today is what it says. But when we come back and do our group meeting on Wednesday, I'll have an idea of what we want to design, and then we can work on that.
Nice. Well, if you need some help or if you feel frustrated with it, just let us know because we can help.
If you guys think of some things too, just give me a text and we'll work it out.
Yeah, I was thinking it would. Yeah, it's gonna be cool to figure it out. It's just trying to figure out who you're gonna target.
Yeah, what you're gonna do.
Target audiences. So.
Yeah. Yeah. Yep.
Yeah.
So sounds good.
Okay. Thanks.
See you guys.
Yeah.